the universe's invisible architects, unraveling the mysteries of dark matter and dark energy in the vast, silent expanse of the cosmos, where galaxies spiral like cosmic pinwheels and stars ignite in fiery bursts. There exists a profound mystery. It is a mystery that touches every corner of the universe, shaping its destiny from the smallest whisper of a proton to the grandest cosmic structures. We see its effects, we measure its influence, yet it remains stubbornly invisible, a silent, unseen force that dwarfs all the matter and energy we can perceive. This is the enigma of dark matter and dark energy, the universe as invisible architects. Imagine, for a moment, that you are standing on a cosmic shore, gazing out at an ocean of stars. What you see, the shimmering nebulae, the twinkling constellations, the distant glow of galaxies, makes up less than 5% of this grand ocean. The rest, the overwhelming majority, is something else entirely. Something we call dark matter and dark energy. These aren't just empty spaces, they're active, dynamic components that dictate the very fabric of reality on the largest scales. For centuries, astronomy was a journey of discovery through the visible. From the naked-eye observations of ancient civilizations to the powerful telescopes that revealed distant galaxies, our understanding of the universe grew with each new light particle captured. But in the 20th century, a strange whisper began to echo through the scientific community. Observations of galaxies and galaxy clusters didn't quite add up. They were spinning too fast, holding together in ways that defied the known laws of physics if only visible matter was at play. It was as if an unseen gravitational hand was holding them together, preventing them from flying apart. The ghostly embrace of dark matter. The first compelling evidence for this unseen component emerged in the 1930s, thanks to the Swiss-American astronomer Fritz Zwicky. He was studying the Coma cluster of galaxies and noticed something peculiar. The galaxies within the cluster were moving far too quickly to be held together by the gravitational pull of their visible mass alone. It was like a carousel spinning so fast that its riders should have been flung off, yet they remained firmly in place. Zwicky, a man known for his unconventional thinking, proposed the existence of dunkelmattery dark matter. His idea was largely dismissed at the time, considered tyrannical. Decades later, in the 1970s, Vera Rubin, an American astronomer, and her colleague Count Ford provided more definitive evidence. They were meticulously studying the rotation curves of spiral galaxies. If a galaxy were composed only of the stars and gas we can see, its outer regions should rotate more slowly than its inner regions, much like planets orbiting the Sun. However, Rubin and Ford observed that stars in the outer reaches of galaxies were orbiting just as fast as those closer to the center. This flat rotation curve was a profound puzzle. The only way to explain it was if there was a vast, invisible halo of matter surrounding and permeating the galaxy, extending far beyond its visible boundaries, providing the extra gravitational pull. This invisible substance was dark matter. So, what exactly is dark matter? The truth is, we don't know for sure, but we have some strong candidates and a growing understanding of what it is not. We know it as not ordinary matter, the protons, neutrons, and electrons that make up everything we can touch, see, and feel. It doesn't interact with light, which is why it is dark. It doesn't absorb, emit, or reflect light, making it truly invisible to our telescopes. It is not made of black holes or neutron stars, as these would interact gravitationally in ways we could detect, and there simply aren't enough of them to account for the missing mass. The leading hypothesis is that dark matter is composed of exotic, as yet undiscovered particles. Scientists have given them names like WIMPs, weakly interacting massive particles, or actions. These particles would interact with normal matter only through gravity and perhaps the weak nuclear force, making them incredibly difficult to detect. Imagine particles that can pass right through you, through the Earth, and even through the Sun, without leaving a trace. That is the elusive nature of dark matter. The search for dark matter is one of the most exciting frontiers in modern physics. Scientists are building massive detectors deep underground, shielded from cosmic rays, hoping to catch a rare glimpse of a WIMP interacting with an atomic nucleus. They are also using powerful particle accelerators like the Large Hadron Collider to try and create these particles in controlled environments. While no direct detection has been confirmed yet, the indirect evidence for dark matter is overwhelming. It is not just galaxy rotation curves. It is the way light bends around massive galaxy clusters, gravitational lensing, the patterns in the cosmic microwave background radiation, the afterglow of the Big Bang, and the formation and distribution of large-scale structures in the universe. Without dark matter, our cosmic models simply fall apart. The accelerating expansion, the enigma of dark energy. If dark matter was a perplexing puzzle, dark energy introduced an even more mind-bending mystery. For most of the 20th century, cosmologists believed that the expansion of the universe, set in motion by the Big Bang, was gradually slowing down due to the gravitational pull of all the matter within it. It was like a ball thrown upwards, destined to eventually slow down and perhaps even fall back. However, in the late 1990s, two independent teams of astronomers, studying distant supernovae exploding stars that serve as standard candles for measuring cosmic distances, made a shocking discovery. These supernovae were fainter and thus farther away than expected, implying that the universe's expansion wasn't slowing down, it was actually accelerating. This was akin to throwing a ball into the air and watching it speed up as it flew away. This astonishing finding, which earned the researchers a Nobel Prize, pointed to the existence of an unknown force pushing the universe apart, counteracting gravity's pull. This force was dubbed dark energy. Unlike dark matter, which clumps together with galaxies and clusters, dark energy appears to be a uniform, pervasive force that acts like a pressure, pushing space itself apart. It is not localized, it is everywhere, woven into the very fabric of spacetime. The most widely accepted explanation for dark energy is that it is a form of vacuum energy, an inherent property of space itself. Even empty space, according to quantum mechanics, is not truly empty but seethes with virtual particles constantly popping in and out of existence. This inherent energy of the vacuum could be the source of dark energy. Another intriguing possibility is that dark energy is related to Einstein's cosmological constant, a term he famously introduced into his equations of general relativity to allow for a static universe, and then later called his biggest blunder when the universe was discovered to be expanding. Perhaps his blunder was actually a profound insight into the nature of reality. The implications of dark energy are profound. It means that the universe's ultimate fate is not a big crunch where it collapses back on itself, or a gradual big freeze where it expands forever but eventually runs out of energy. Instead, dark energy suggests a big rip scenario, where the accelerating expansion eventually becomes so powerful that it tears apart galaxies, stars, planets, and even atoms themselves. This is a terrifying, yet distant, cosmic possibility. The cosmic inventory, a universe of the unknown when we combine our understanding of dark matter and dark energy. The cosmic inventory looks something like this. About 5 ordinary matter stars, planets, gas, dust, us, about 27 dark matter, the invisible scaffolding that holds galaxies and clusters together, about 68 dark energy, the mysterious force accelerating the expansion of the universe. This means that over 95 of the universe is made of things we cannot see, cannot touch, and do not fully understand. It is a humbling thought, a testament to the vastness of our ignorance and the boundless potential for discovery. The quest continues. Peering into the darkness, the quest to understand dark matter and dark energy is driving some of the most ambitious scientific projects of our time. For dark matter, experiments like Xenant and Lux Zeppelin are trying to directly detect WIMPs. Scientists are also exploring alternative theories, such as modified Newtonian dynamics MOND, which proposes that gravity behaves differently on galactic scales, eliminating the need for dark matter. However, MOND struggles to explain all observed phenomena, particularly in galaxy clusters. For dark energy, new generations of telescopes, both on Earth and in space, are mapping the universe with unprecedented precision. Projects like the Dark Energy Survey DES and the upcoming Euclid mission are creating vast 3D maps of galaxies to track the universe's expansion history and better understand the nature of dark energy. Gravitational wave observatories like LIGO and Virgo are also opening new windows into the cosmos, potentially offering new ways to probe these elusive components. The mysteries of dark matter and dark energy are not just abstract scientific puzzles, they are fundamental to our understanding of how the universe began, how it evolved, and what its ultimate fate will be. They challenge our perceptions of reality and push the boundaries of human knowledge. As we drift through the cosmos on our pale blue dot, surrounded by the visible wonders of stars and galaxies, it is a profound thought to consider the invisible forces that truly govern this grand cosmic dance. Dark matter, the unseen glue, and dark energy, the relentless pusher, are the silent partners in the universe's grand design. They remind us that even in the most well-lit corners of our scientific understanding, vast stretches of darkness remain, waiting to be illuminated by the relentless curiosity of the human mind. Perhaps, one day, we will fully unravel these cosmic enigmas. Until then, they serve as a constant reminder of the universe's infinite complexity and the endless wonders that lie just beyond the reach of our current perception, inviting us to keep looking, keep questioning, and keep dreaming of what else might be out there in the vast, silent, and wonderfully mysterious cosmos.